Hi, so from today we are going to do time series analysis in R, in which you will be doing first of all basic metrics, then you will be doing linear regression in matrix form, then we will be doing time series analysis, then we will be doing time series analysis in uh, Bayesian methods. We will be doing Box Jenkins, then we will be doing dynamic factors, covariant, jags and stance. Okay, so if you want to learn all this, you have to stay tuned with me. Now let's start with basic metrics. You know that for creating metrics in R is the command. You will pass the number, like I am passing 3, then you will be passing the number of rows and the number of columns. So very basic metrics will be formed here. Just quickly do all these bullshits. Now this will create from 1 to 12, and if you want your 1 2 3 in non-vertical, or you want it in like from rows, what you will be doing is same. You will just do by row is true. I think you know all this. So this is, and you can check the dimension of, just let's put this one. You can see it's 3.4 is the dimension. You can check all classes. Type of, as you can see, type will give you the type of the materials or the components inside the matrix. So it's done. And if you want to convert into a data frame as data frame, and you just run, so you'll get 3 observation and 4 variable. You can expand and you can see, right? So this is first thing in basic metrics. Then you will have to do addition, subtraction, all these things we'll be doing within a minute. Suppose you have a matrix of A, you have a matrix 1 to 6, and you have 2 rows and 3 columns, and B is another matrix, and same 1 to 6, you have 3 rows and 2 columns. Just run it quickly, you'll get one A and B. Now what if you do A multiplied by B? You will get error by saying that non-conformable arrays, right? Because A has a dimension 2 by 3 and B has a dimension of 3 by 2, right? So if you multiply it, it will give you error by saying this, right? So what if you like, but in theory you could have multiplied this two, right? Because it's 2 by 3 and it's 3 by 2, so it will give you a 2 by 2. So to do a matrix multiplication in R, you have to do A percent multiplication percent B. Okay, so this will understand that it's a matrix multiplication and it will give you the result. Okay, matrix, like matmul function you will use in TensorFlow or NumPy. Same thing you could try. This will also work. See, it's 3 cross 3. Now quickly, another concept is transpose. So do the same matrix multiplication of transpose of A. This will also work. Remember, for transpose T. Now it's done your subtraction, addition and multiplication. Quickly go through the subsettings. Now if you have A matrix, again take A, data will be 1 to 9, number of rows will be, let's say, 3, number of columns will be 3. It's very sophisticated. So you'll get A, and we are getting error by saying that we have misunderstood. So now if I want to write this command, what will I get is that now if we just run the whole A, so this is a subset of A and this is basically the first 2 rows and all columns. Same thing can be done here with this command. It's I want all the rows of the second column, all the rows of the second column, sorry, yeah, all the rows of the second column. And if I want any specifics, like I can pass this for only first and third row and columns, you get that. So this is how you do subsetting. Now next thing is that diagonal matrix and identity matrix, which you wants to know. So for that, the command in R is diag 1,3 will be the detection, and you will have a diagonal matrix. Okay, so 1 is the diagonal element value and 3 is the 3 cos 3 matrix, because as you know that you cannot have a diagonal matrix if your matrix is in a rectangular shape, right? Now this is a standard, you can change anything. You go for 4 and 3, you will get a 3 cross 3 with 4 in its diagonal. Okay, you can solve any equation. Or if you want different values in your diagonal, you could also do that, like this one. Now if I say A is my matrix, okay, this is my matrix, I want 3 in every place, and it will be a 3 cross 3 matrix. If you print A, we'll have a value of this. Now I want the diagonal of A to be 2. If you print A, you will get all the diagonals is converted into 2. Now suppose we're doing the very last thing to close this diagonal matrix and all. I again took one A with a matrix of 9 cross 9, and I took one identity as diagonal of 3, so I have A and 3, right? And if I do A percent to multiply percent I, what do you think, what should I get? We get another matrix which does not have any particular form. Okay, so everything is clear here. Now the only last thing left is inverse. Then will be a champion matrix. So now suppose you took A equals to some diagonal, okay, and you want to add a matrix of, so you'll get some value of A. Okay, it's a completely random value. So the inverse of A, for this the command will be solve for A, and you will have an inverse. And how do you convert the inverse? That you will convert, how do you confirm the inverse? You just multiply it with A so that you can get a identity matrix, right? So let's just run it quickly. I have A, I have inverse of A, and this multiplication, as you can see, is giving me 1 1 1. These are very negligible term, e to the power minus 18, minus 17, so these all are zeros. Basically we will have, this is our inverse. Okay, so if you just print inverse of A, we'll have a value. And another method in matrix, if you have studied in matrix algebra in your +2 or in your college, you will find its Cholesky decomposition. So how to do that? I have A my, okay, and so in case of inverse of A, I will give Chol to inverse. This is the sign, and I will pass A, and it will do the inverse trick. And I just copy this, paste it here, and run it, and as you can see, it's 1 1 1, and everything is negligible term, 0 basically. In mathematics, or sorry, in computer, it's very tough to get 0 0 0. So that's it. Congratulations. End of matrix algebra. Now we'll move directly to linear regression with matrix. So now we are in linear regression in matrix form. Basically, you know what we require. We require the libraries stats, yep, we require Mars, which I have not installed here, so we'll go there in packages, we'll type Mars and we'll install. And the last library we required for data is data sets. So everything is done, just run all these three. So we have our packages installed. If we use stack loss data, so just go data, see stack loss is there, and just optional you can provide data sets and package, and you run this. As you can see, you have stack loss. Let's see, data equals to stack loss, and let's just print stack loss in console. Yes, probably you haven't seen this. So this is what the whole stack loss looks like. 4 variables. Let's do 1 to 4 and run it, and if we just print the data, this is part of the data basically in matrix form. Now how to run a OLS, or basically regression. I think you know LM is the formula. I will be providing stack.loss, and it will be providing air.flow as my variable. Okay, and data will be data. So as you can see, it's basically a y equals to mx plus c. So what it did, it's that it will give you a equation like stack loss equals to, my coefficient is minus 11.616 plus some variable like m. Your m is 0.641 times air dot flow, and you will also have an error term, right, plus e. So this is okay, but you have to understand this e basically follows a, I don't know how to write n, normal distribution with zero mean and some sigma as its deviates. Okay, so it's probably sigma square. So this is the whole equation that we get from this LM. So you have to understand that what basic regression does. Now if you have to do it in a matrix form, what you will have to do, like basically what you have did till now in data frame or all other things, it's same, that you will be stacking the values of stack loss and airflow in both the side. You will have a bias term, or you will have this alpha beta like coefficient and intercept and the error terms, right? So in case of matrix model, let's probably say it as a fit and call the same formula. Remember what's our data? Our data is just these 4 lines, right? So we call fit, and then take one variable and we'll call model.matrix. In stack stats package you have model.matrix. You want to model it at matrix, and we'll just call the fit. We'll have a value of z. Now if I print z, this is what you will get. You will get intercept, you will get airflow value. Okay, so if I just wants to print this is what our data will look like. Now we have to solve this for parameters. So for solving like in a matrix form, if you taken the course of Andrew Ng or some books like machine learning, TensorFlow, or not any book like in linear regression, you will find that what's the weight, if you solve for weight in matrix form, what is the value you will get for x or your w weights is basically nothing but this z. You will be getting, let's write it, you will be getting the transpose of z. So let's put it on zt times z, and it will be a inverse 1 times zt into your y, right, times y. This will be, you are getting as in matrix form if you solve. So this is when valid when you have a very less amount of data. So in that case, solving for gradient or some other method optimizations will be very mathematically, computationally expensive, and you will go for simple matrix multiplication. Okay, so if we try to solve this in this manner, what we will be requiring, as you can see, the whole function is stacking upon z and y, so we'll be requiring y and z. So let's just give the value y as, it will be also a matrix, it will be your data's, what is y, stack loss, and number of columns required here is as 1. So this is our y. Just print y. This is our y is 42, 37, 37, 28. You can also confirm here, right? Now next what we required z. So what will be z? Z will be the bias term, which is 1, that will be, it's gonna multiply like x0 basically and your x1, which is airflow, right? So how to do that? It's basically cbind 1 and data airflow, right? As you can see, if I now just print z here, I'll get an error. Why? Because I have taken capital Z. So this is the Z. Now I have to find the value of like theta or omega, the weight values. by applying this equation. So how to do that? That's why we have done matrix all this bullshit, because for this equation you required, so solve, how to solve this. For inverse, we know we have to apply solve. First thing is transverse of z, so t of z and a multiplication of normal z, right? So it's done. Then a matrix multiplication with zt, so that means basically t, and you pass z, and for all this it will be a multiplication of y, right? So this is what our equation for weight, and if you just run it, you can see it's minus 11.62.64. As you can see, the same thing from this LM formula. So now we have understood how this formula equates this value. As you can see, the same thing happens here. Now we can basically add the this is univariant, right? Now it's pretty clear. For multivariant, what will be? So like fit dot multi, and we'll do the same LM stack loss, and give a dot, and just pass the data equals to data, and you have done your multi regression and all that. You now require that z here also, which will be model matrix, and you just pass fit multi, and we'll have your z, just print z plus 4 rows, and you have this. Okay, as you can see that stack loss is removed, as that's your y. Now we have to solve the same. Like first, if you just print your fit multi, you will get this, all this intercept, airflow coefficients, and you know by the same principle what is your equation gonna look like. It's just the same, you have to change here, it will be a error term, right? And we're gonna solve by same, just copy and paste all this. Your y will be same, and your z will be I think you have your z right by this model matrix method. You don't have to do all this. So what you do here, you will just assign this first 4 row as your z, so that you don't have to write all that nonsense. And now you just have to solve the same thing. Just run it, you will have the same equation, intercept and all that. As you can see, minus 524.9, minus 524.9, and all that 5. Okay, so you have understood how linear regression works. in case of matrix form, it's basically the whole term what we have done here up to. It's called normal equation. So you don't have to do anything like in if you are doing it in what gradient descent and all that. You have to do regularization. You have to do like LR, learning rate and all that. So now the second matrix form. We need to solve, which is basically y equals to z times x plus your error term, right? But I don't think that this like required in your case. You are doing this is purely academic purpose. So if you don't do this also, like this method, finding alpha, beta and all that, it will still work. So in this video basically you learn how to do a normal equation and solving normal equation from matrix in R. So that's it for today. Thank you.